So we're going to look at if-then statements, and we're going to match them up to the reference sheet that you have next to you. So the first thing you do is you look at what their if statement is, which is their hypothesis, and you see what you can do with this based on what would be on your cheat sheet or your reference sheet. So in here you see that you have 1 equal 2 and you have 1 equal 3. And if you notice, there are 2 1s. And so what we're going to do is we're going to get rid of this 1 and we are going to put the 2 in its place. And we're allowed to do that because of something in algebra. So we're going to come over here and look for an algebra reason, which is at the top of the page, that allows us to take something out and replace it with something else. So as I scan down through, you might remember this substitution idea. Substitution is a property where you can take a letter out and replace it with another letter as long as they're equal to each other. You can do it with numbers or letters. Okay, so that's what I'm doing here. Angle 1 is going to come out and 2 is going to go in its place. So I would be able to conclude, which would be my conclusion, that the measure of angle 2 equals the measure of angle 3. That would be what I would conclude. And the reason I'm allowed to do that, my justification for it, is the substitution property. Make sure you abbreviate with more than just sub, or it might be subtraction. So you have to add more to show it that. And you can abbreviate, but this is substitution property. Okay, next. We're going to go down to number 5. Skip to number 5. So it says angle 7 and angle 8 are vertical angles. Okay, so let's just sketch a little mini picture of this. I'm going to draw 2 intersecting segments or lines, and I'm going to put 7 and 8 opposite of each other. And I'm going to remember that, oh yeah, we learned in the first chapter that vertical angles are congruent. So now I'm going to say, okay, well, if this is my hypothesis, what would I be able to conclude about 7 and 8? And I would be able to say that angle 7 is congruent to angle 8. And the reason is, we're going to find that, it's on the back side, it's number 17. It's called the vertical angle theorem. So you can either write VAT for vertical angle theorem, or you can do this fun little acronym, which is VAC, which stands for vertical angles are congruent. I like to use VAC, but you could call it VAT if you want to also. So I'll just say VAAC, vertical angles are congruent. Okay, number 6. I have angle K and angle L are complementary. So what I know about complementary angles is they add to 90, but I'm not really sure how I would write that. So I'm going to go to my cheat sheet first and find complementary. It's located under definitions. So we're going to go to number 24. And it says 2 angles whose sum is 90 degrees. Okay, so behind that, I'm going to write out the measure of angle 1 plus the measure of angle 2 equals 90 degrees. I'm just going to write it like that so you know that is what it's going to need to look like when I use it in a proof. I'm going to put it as an equation. So I'm going to come back to the problem I'm on and I'm going to say, okay, well, the measure of angle K plus the measure of angle L would need to be 90 degrees. And the reason I'm allowed to do that is the definition I just looked up. It's called the definition of complementary angles. And you don't have a lot of room there, so you can abbreviate DEFN for definition of comp angles, and I'll know what you're talking about. That justifies what your conclusion is. Okay, number 7. I have 2 angles that are congruent to each other. I'm not really sure what I could do, so I'm going to go look at my definitions. So I go to my cheat sheet, and I'm going to notice, and you haven't used this one before, so this would be brand new, the definition of congruence. So let's take a look at the definition of congruence. If 2 segments are equal in measure, then they're congruent in size and shape. Conversely, which is the converse, if they're congruent in size and shape, they're equal in measure. You can also do it with angles. You can change from equals to congruent. So let's go back to what you're doing. This one says they're congruent. So if they're congruent, then we would be able to conclude that the measure of angle 5 would have to equal the measure of angle 6. That would be allowed because we just read if angles are congruent, then they're also equal in measure. That is the definition of congruence. So if you're wondering where I got the definition of congruence, I'm just stating the reason that's listed in my cheat sheet. That's the reason in bold of what allows you to do that. Okay, number 8. If 3 and 4 are a linear pair. All right, so let's go find linear pairs. So your first thing might be, hey, let's go look at our definitions. Do you see definition of linear pair anywhere on there? That's because we don't use the definition of a linear pair. It's awkward and it doesn't really tell us anything besides what they are. So I want you to go to the front of this and go to number 13. In our book, it's called the supplement theorem. In some books, it's called linear pair postulate. So if you are a virtual student, write in linear pair postulate so that you have that, and that way you can use both and you'll see both on these worksheets. Okay, let's read it. If two angles form a linear pair, then they are supplementary. Okay, so let's go back to the problem we're doing. We have a linear pair, so what would we be able to conclude? Well, the supplement theorem said they were supplementary. And so since it says they're actually supplementary, that's what I'm going to write. I'm going to say angle 3 and angle 4 are supplementary. And the reason is going to be the reason in bold. So you can either call it the supplement theorem or the linear pair postulate. And you can even put LPP if you want to. So I'm going to use the supplement theorem because that's how our book says it, but you can say the linear pair postulate. Okay, number 10. If B is the midpoint of XY. So let's go ahead and make a segment XY, and we're going to put B as the midpoint, and we're going to tick, tick, like you were taught in chapter 1. So I know that I have a midpoint. See how the key word is midpoint? So let's go to your cheat sheet and look for a midpoint. And a lot of you might guess that it's a definition, and it totally is. So midpoint is the very last one, 26. So it says a point on a segment that divides a segment into two congruent segments, or sometimes we say two equal segments. I'm going to use the congruent part because that's what came first. Okay, so come back over here, and if you look at what would be congruent from the picture, then segment XB would be congruent to segment BY. Now, if you said they were equal, you could say XB equals BY, and you wouldn't put the little bars on. So these would be your two options of what you could say. They're either congruent or their measures are the same. And then we would say our justification is the definition of a midpoint. And where did I get definition of midpoint? That's the bold word that we just read right there. So the bold word is the reason why you're allowed to say what you're saying. Okay, we're going to do one more, and then you're going to go try the ones we skipped. All right, so this one says if points A, B, and C are collinear and B is between A and C. All right, so let's draw a picture. A, B, and C are on the same line, and B is between A and C. Now, nothing tells you that you have a midpoint. Nothing. It just says B between. It doesn't say in the middle. So the only thing you would be able to do is, well, let's go to the cheat sheet and try to find something we can do when we have collinear in between. So this is going to be on the front. This is going to be number 11. What we can do if we have things that are collinear and one of them's between is we can make an equation that adds up the two little dudes to equal the big dude, like we were doing when we did the candy bar example, and we broke it for our friends. So we come back over here and we apply that to our picture. So we know that the measure of AB, so we just put AB plus the length of BC has to equal the length of AC. Now, what do we call it? Well, we call it based on what the name is for the postulate. It's called segment addition postulate, which I kind of mentioned to you earlier in the year. You may not remember it, but it's called the segment addition postulate. Okay, so now what I'd like you to do is try the ones we skipped. So if you're on video, you're going to pause it and try the ones we skipped, and then we're going to go back and check them.